Hello, physical science students. This is Mrs. Lewis. If you are watching this short clip video, it's because you missed our lab station day, okay? So this is 5 different stations. We are currently on chapter 9, and we're learning all about waves. You can find a copy of this packet in the comments below. In Google Classroom, it will be attached for you. So for our first mini lab station, our lab station 1, we were supposed to place a textbook flat on our desk and line up 4 marbles. And this is a 2-person job, and I'm a 1 person with a broken finger, so I'm going to do the best I can. So we're supposed to line up 4 marbles, okay? And once we line up those 4 marbles, it tells us cover the first 3. So this is marble 1, marble 2, marble 3, and it also says they need to be touching. Okay, and then it says I need to come in and I need to tap with the pencil my first marble and see what happens. So let's look at that again. Not too bad for a missing finger and a missing partner. Okay, so one more time. I'm going to cover up those 3 marbles. I'm holding them down on the book. This 4th one is loose. Okay, I'm going to tap the 1 marble that my finger is on. And there's movement. So for this lab, you were supposed to write a paragraph explaining how the 4th marble reacted to the pen tap, and then draw a diagram showing how energy was transferred through the marbles. So for our demonstration number 2, our materials are going to be a bowl of water and a small rock. Our procedure is wait until the water in the bowl is still, and when the water is still, we're supposed to drop the rock into the bowl. Let's do that again. So the questions for this part of the lab: when you toss the stone in the water, how does it start the motion of the wave? And why does the wave spread out as it moves? Now we have a new bowl of water because this is demonstration number 3. Your materials are a ping pong ball, a pan of water, and we have a rock. So what it asks us to do is to place the ping pong ball in the pan about halfway between the center and the edge of the pan. And obviously I'm not using a pan, I'm using a bowl. And we have to wait for it to stop moving. So I will tell you this: if you want to learn whether or not your floor is level in a classroom, try to do this lab. So I've kind of had to shimmy up my bowl a little bit, and it may not work perfectly for you, and that's okay. What we're wanting to do is notice how the ball reacts. See if I can't get this angled differently. So the ping pong ball is in the pan. It's about halfway between the center edge of the pan. And when the water's still, and it is, but it's not level, right? I'm going to drop the rock into the pan, and I'm going to notice what the ball does. I'm going to do that again for you. Keep your eye on the ball. And I'm going to help you a little bit. The ball is going like this. The ball's going up, and it's going down, and it's going up, and it's going down from the waves. So the question here is, what do waves carry? Quite honestly, demonstration 4 is not an easy one to show you because I don't have anybody to really hold the camera and everything's attached to my desk. So here's how you do it if you want to try it at home. You need a rope and a broom. The procedure is tie the end of a rope to the handle of the broom. Rest the broom upright in the corner of the room and send a wave through the rope. Misspelling. So where did the energy that caused the broom to shake or fall come from, and how did the energy get to the broom? And I appreciate you understanding my typos as it's a little difficult to type. Okay, so our 5th station and our last demonstration of the day was to fill a pie plate or a bowl about 2 centimeters deep with water and observe, and we were going to tap with our finger, tap, 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 tap the water, okay? And we're supposed to do that once every second. So 1, and then tap again for 2, and then tap at the water again for 3. So every second, 1, 2, 3. And while we're doing that, we should be observing, excuse me, the surface of the water and the spacing of the water waves. You're not actually measuring with any kind of instrument the waves. I just want you to see how close together or how far apart the waves are, okay? Is it short? Is it long? And then you're going to slowly increase the rate of your tapping on the water with your finger and continue to observe the spacing of the water waves and notice what happens. We're watching the water. That's 1 second. Find a different way to see the wave. And to be quite honest with you, this is probably not the best camera as it does not keep up with the action of my finger. I'm hitting about 10 times per second the water and it just looks like a blurry mess. So basically what you should see is as you tap just once per second, you'll notice that the wave is like one big large wave and it carries from the middle of that tap all the way out to the end of the bowl. And when I'm tapping 10, 15 times an hour, my waves, there's more of them, but they are shorter, okay? It's more of a small ripple. So that's what you should have noticed there. And the analysis of this lab was describe how the spacing of the water waves relates to their wavelength and to describe how the spacing of the water waves changes when the rate of tapping increases. And that concluded what we did. Don't forget that your lab books for lab number 3 is due Thursday morning before first hour.